So the next programming assignment will be released shortly, and when you take a look at the assignment, you'll see that one of the things it has you do is develop client-side proxies using Retrofit, or more specifically, Retrofit 2. So I thought I would spend a little time here explaining how you can generate retrofit interfaces or proxies rather than having to write the code yourself the old-fashioned way. So to do this, let's start by just taking a quick look at the old way we've been developing our proxies through many of the examples and the assignments up to this point. And to do this, we're going to do it in the context of the quotes services application. And in particular, we're going to take a look at a class I created called Quote Proxy Legacy, which is the old-fashioned way of writing proxies. So as you can see here, the old-fashioned way involves making a class that's a component. We make a REST template. We're going to auto-wire, and that auto-wired REST template will be created by some kind of bean like this one, where we're going to make a new REST template. We're going to connect the gateway URL to it, and that will then be auto-wired in here. So we have to do some of that ourselves. And then we would write all the proxy methods manually. So here's an example. Here's get all quotes. This is the method that's going to take the route to the microservice that performs the request, which could be either the Zippy microservice or the Handy microservice. And it creates a URI that includes the route followed by the particular endpoint we're trying to get to, get all quotes in this case. We build a URI, then we make a request using our make get request list helper method, which we wrote. If we didn't have this, it would be even more complicated. And we basically do this for each of the different methods that the client wants to use to access services provided by a microservice via the API gateway. So again, here's get quote. We go ahead and add the quote ID and the path, and we make the request, making a get request. Similar things for post. So each of these methods is tedious and error-prone to write, and therefore we would like to try to find a way of being able to simplify things. Okay, great. So far, so good. So we'd like to get away from having to use this. Now, what we want to be able to do is have an API written using the retrofit model, and we'll talk more about retrofit here in class, but just to note, this is actually very similar to the HTTP interface clients mechanism that's provided with Spring 6. Similar kind of idea. It's just a little bit more portable because it runs in earlier versions of Spring than Spring 6. So we would have a quote API, and then we would define a bunch of proxy method declarations annotated with retrofit annotations in order to be able to tell retrofit what to do. So I'll talk about this in more detail later, but the key thing I want you to note is there's a bunch of stuff you have to write. You have to know how to make the right get annotation here. You have to know what annotations you should be providing for the parameters that are being passed here, the return value, and so on and so forth. And that's not the hardest thing in the world, but gosh, it's a lot of work. And wouldn't it be nice if we could automate this? Well, it turns out that you can automate this. And let's take a look at how we can do it. So let's go take a peek over here at the base controller. If you recall, the base controller was the base class, or the superclass in Java that we used to derive the Handy microservice controller and the Zippy microservice controller. So here's the base controller. And you can see it's got a bunch of various annotated methods like get mapping, and that are annotated with get mapping and post mapping, which are essentially the endpoint handler methods that are going to receive the appropriate incoming HTTP get and post requests. So we've already got these methods annotated with the appropriate annotations that Spring understands in order to be able to work properly and be able to take the incoming requests and encode them, or rather decode them from what's sent over from the client side. So wouldn't it be nice if we could take this file and then use it in order to be able to automatically generate the retrofit interface? And I'm going to show you how to do this using our good friend ChatGPT. So here we are over in ChatGPT. Let me see if I can make this a little bigger so it's easier to see. So the first thing we're going to do is we're going to use the advanced data analysis feature, which allows you to take a file, like we're going to take the base controller.java file we were just looking at, and we're going to go ahead and we're going to read it into ChatGPT. And then we're going to give ChatGPT a prompt. So here is the first prompt we're going to give to ChatGPT. We say, please analyze the attached Java file, that's basecontroller.java, containing a Spring base controller, and generate the corresponding Retrofit 2 interface named quote API that can be used by a client to invoke remote method calls on this controller. So let's go ahead and hit return. We'll submit that to ChatGPT, and we'll take a look and see what it says back in response. So you can see here it's reading the file, and then it goes ahead and tells us it's going to generate the Retrofit 2 interface. And it also kind of walks through the steps it's going to be doing to do this, which is very helpful. And that's primarily because I have told ChatGPT to tell me the work it's doing in the custom instructions that I provide to ChatGPT. So here it goes. So it tells us what it's going to do. It's going to identify the endpoints, which are the ones that are marked with get mapping and post mapping in the base controller, identify the parameter and return types, identify the annotations for the parameters, and then adapt the return type. Now, you'll remember in the base controller file, it was meant to be generic. So we ended up using a return type of type T. So we're going to have to do a two-phase pass on this to make it all work. So here's the first thing it does. You can see it makes an interface called quote API, and then it starts putting in the various retrofit annotations. And you can see here that it has the various methods with the appropriate annotations, either get annotation or post annotation. They all return something called a call. We'll talk about a call later. You can see that it's going to pass in various parameters, like here's a query parameter, here's a body for a post request. All these things have bodies. It has a query, which is a query parameter, which is the Boolean that we pass in here. And other things to note very quickly, you'll notice that because the base controller had a return type of type T, it just has this thing return a type T. However, we don't want to just return type T. We're actually going to have lists of quote objects. So we're going to tell ChatGPT to do a few augmentations to this generated code in just a moment. We're now going to give it a new prompt, and this prompt says, please regenerate the quote API interface with the following changes. Replace the generic parameter T with list of quote for all the call return types. So that's the first thing it's going to do. So it's going to replace this with call to list of quote. And then we also said, please add a path annotation as the first parameter to each of the quote API methods. And that's because the way we're going to be using Retrofit is to do this dynamic path feature where we can insert the appropriate microservice route name in the request. And it's going to do it for us automatically, which is very cool. So you can see it understood what we asked it to do. And now it generates the right version of the quote API. So you can see that it's replaced call T with call to list of quote, which is exactly what we want. And you can see how it put the path here at the beginning of each of the methods. And this is actually what we need to have for the retrofit version of quote API. And when we look at the code, you'll see how that gets done. So that's pretty nice. So now we've actually got ourselves the retrofit API generated automatically from the base controller. There's one more thing we're going to do here. So the last piece of the puzzle is we're going to give it yet one more prompt saying to generate a bean factory method named getQuote API that returns an instance of the quote API interface that has the base URL set to the Java string constant gateway base URL. So now we're actually making the factory method which will create an instance of quote API. So once again, we give that to ChatGPT, and lo and behold, it knows exactly how to do this. This is something that isn't that hard. You can take a look on the web to find examples of how to do this, but hey, why do we need to do that when we can have ChatGPT do it for us? And you can see what it does is it's going to use the retrofit builder to make a new retrofit instance, connect it to the gateway base URL, add the appropriate JSON converter factory, and then build that into a retrofit object, and then say retrofit.create and tell it to make us an instance of the quote API object using the class as the parameter. Now, again, we don't need to have this here because this is done for us in our constants file, but you could pretty much cut and paste this. In fact, you could say, to be even better, please generate inline Java doc style comments for the generated getQuote API method. because of course we want to document our code. And so now it generates the Java doc interface here, explains what it's doing. So even nicer than having to write all this code yourself, it can do it. And you can see it even generates little comments here in line that you could reformat to follow the convention that we use here in class. So really nice feature. ChatGPT can be used to help simplify things. And this particular example we just discussed will be very relevant in your upcoming programming assignment 2A, where you have to create a retrofit interface for the way we're doing our code that's accessing the database that you'll do for assignment 2A.